So, good morning. My name is Chalindinita, and today I am presenting my project Hallucination Detection in LLM using the hidden state props and fine grained SAMP highlighting. So, first I will go with the table of content part. So, in this presentation, I will quickly work through the full story of my project. So, I will start with the what we call it, so problem and motivation, then the research gap, and then the aim and the objective. After that, onion diagram and the shareholder list, and I will show the rich picture also. Then I will cover the requirements, system architecture, and the low level workflow. So after that, I will show my prototype progress and time schedule, and finally I will go through the conclusion and the reference part. So next we will move on to the problem and research motivation. So what is the problem? So the main problem is that the LLM can give answers that sound correct, okay? So but actually contain wrong facts. So these mistakes are called as the hallucination. The hard part is that hallucination often look confident, so users may trust them without checking. So therefore, like, also many existing method only say this answer is wrong, but they don't. It means like, but they do not clearly show which exact part is wrong, right? So according to that, so my motivation is to build something more practical where the system can detect risk early and help the user quickly. So and see it means like see what part need checking, and especially for the important area like for the education and the health and the decision making likewise. So next, I will move on to the research gap part. So, in my project, my main focus, it means like I mainly focus two research gaps, right? So, my first gap is detection during generation. It means the most system detect hallucination after the full answer is generated, right? But I want detection during the generation. So use it to do that. I have to use the internal signals. So you using internal model signals like hidden status and uncertainty signals. So risk can be estimated at the token level while the model is the producing the answer. So that is my first research gap, and then I have the second research gap. So second research gap is like like many approaches only give one final label like hallucinated or not hallucinated, something like that, right? But in real use, it is more use. It means like it is more helpful to like highlight the specific incorrect part like a wrong name, number, or date, or it means like date it or entity, or instead of blaming the whole answer, like it is very clear if I like highlight or something like specify some what is the wrong part is, right? So then that is these two are my research gaps. So next I will go with the aim and objective. So uh, my main aim is to build a prototype hallucination detection system that combine two things, right? Using the internal model signals to estimate risk and highlight the um highlighting the risky spans to the output is easy to understand. So to do that, my objectives are the generate answers and capture the token level signals. And then I have the exact hidden state and uncertainty feature like entropy and margin. Then I have to like train a small probe model that predict risk per token. And I they again I have the it means like risk per token, and like highlighted it means like highlight risky spans in the final answer. And then I have the evaluate the results using the token level and sample level checks, right? So these to do this, these are my object to do this. So next I will go with the onion diagram. So my onion diagram, so this is my onion diagram. So this onion diagram shows the shareholders in layers, right? So in the center, this is the product which is my hallucination detection system. And the layers help me like explain who is closest to the system, and who affect this who it means like who affect it from outside. And it help in requirement thinking, because like because it is different groups have different needs and risk. So these are the things it will represent in the onion diagram. So this is my onion diagram. And then I will move with the so next I have the shareholder overview. So shareholder, so in the onion diagram we are identify our shareholders, and then we are go with this shareholders. Our shareholders is like ML expert, LLM expert, product owner, likewise. So next we have the shareholder overview. So I will go with the shareholder overview. So it in this part it means like here I am summarizing the key shareholders, right? Not like all the one, I'm like summarizing key shareholders. So first I will go with the product owner. So the product owner or the system owner, like they are defines goals and constraint. And then AI engineers and developers integrate and deploy the pipeline. And then in the testers and QA check correctness and whether the highlighting part is reliable, likewise. So then we have the LLM expert and the ML expert. So these experts support interpretation and like model evaluation part. Then we have the data engineers. So data engineers manage data set and labeling for the evaluation part. Then we have the end user. So end users like want trust signals and clear explanation quickly. Finally we have negative shareholder also, like attackers and hackers and competitors, because like misinformation and misinformations are real risk, right? So these are the our negative shareholders. So next I will go with the what we call so rich picture. Mm. So this is my rich picture. So this rich picture show the big story of how user interact with the LLM output, and where the hallucination created failure point, and likewise. So the key idea is users often receive answers fast, and like trust them, right? If a wrong fact is mixed inside a fluent answer, the user may not notice, right? So my system fit into this situation by giving a warning and highlighting the risk part, so the user can verify it quickly. So that is basically what this in this what will happen in this part. So this is like a rich picture is like a big story about this hallucination in LLM, uh, this part. So next I will go with the requirement part. So now, like we have the requirements, right? Must have one, should have one, could have one, and won't have one, right? So it means like I used MOSCOW to like prioritize the requirement, like to prioritize the requirement. So must have means like it means like we must do these things in our system, right? So it must have means like in the must have we have to generate answers and capture token level hidden state and uncertain signals and train load a probe and compute a risk score and highlighting risky span in terminal output. So that is the things we must like we have to do, must we have like must things we have to do. Then we have the should have one. Should have means like we have to do it like it is not must one, but it should. So in this should have, we have to like use a small benchmark set like a truth QA subset, and then provide it means like reproducible script and the basic evaluation metric like precision recall and F1 at the token level. So that is what we have for the should have requirement. And then we have the could have one. So could have, in the could have we have to like add reference based check for mismatches and improve threshold training and opportunity to show the LLM. It means like HTML highlights likewise. So finally we have the won't have one. What is this won't have one? So in this won't have one, like in this won't have one, we have the large scale production deployment or full automation for ground truth labeling across all domain output at this stage. So these are the things in the requirements part. So we have the must have, could have, should have, and won't have requirement. So then I will go with the system architecture part. So in this system architecture part, basically, so in this slide show the system as a three tiers, right? Which means three main layers that work together. I will draw the diagram, and I will put it in this part also. So it is like a diagram, and it has the three main layers and that work together, right? So first I will go with the this presentation layer. So this is the terminal interface where I ask a question and see the answer plus their risk and the highlight. And then I will go with the application, or we can call it as a logic layer. So this is the brain of our system, right? It includes the generation module and signal capture, prop prediction and highlighting module. So finally we have the data or a storage layer. So in this layer store the data set and save output like token signal hidden state and the train prob model and squat token likewise. So it means like so in simple word, the topper layer is what I see, right? What I see is the topper layer. The middle layer is what process the, it means like what is happening inside that. It means like process of the work. And the bottom layer is what stores the data and the result. These are the things in the we have for the final layer. So then I will go with the next part. Okay, next we have the low level workflow diagram, right? So this is the step by step pipeline of how the system works, right? So first, I generate an answer using a small chat model called the Tiny Llama, and then while the model generates each token, I capture it means like I capture the signals per token, like the token IDs and the uncertainty value, and also the last hidden state vector. Likewise, then I train a prob model, which is basically a small classifier trained on the labeled occupied data. So that is what happening in here. So after that, I score each token using the prop, and I get a risk. It means like I get a risk probability per token. Likewise, then finally, I rebuild the text from token ID and merge a risk token into SWAM, and print the answer with highlighted. It means like highlighted risky spam in the terminal. So that's what happening in the in the step by step things happening inside this system. It means like inside to build this, I have to like go through these steps to build this system. So then I have the so then I will move on to the next part. Okay, now we have the what we call the prototype progress, right? So in this slide shows what like my current prototype can. It means like what my current prototype can do already can do. So that's what shows in this what we call the shows in this the screen. So first I will it means like I can explain like this. So it can load the train prob model, and it means like in this part I'm like telling I'm telling it can load the trained prob model and computer risk score per token, and read the captured token signals. Then it display risk statistic like the max. In this part you can see in this part we have the so max mean, and then we have the show it means like max mean what we call the shows the top risk. It means like the top risk token, and give an overall verdict the high or low risk, right? It is like high risk or low risks, right? Likewise, uh, so this provide that the pipeline works end to end and gives the visible evidence in the terminal. So in this part like I have provided a terminal, and this will show okay this is a final result is like this is a low risk one. So this what happening inside this thing. And then I will move with the time scheduling part. So basically this slide show my time scheduling in simple terms. Like I have already completed the code prototype pipeline and the interim demo work. Next, like I focus is like improving the quality of the training data and doing wider testing and completing the store stranger evaluation. So the it means like so the system is more accurate and more reliable for the different type of questions. So basically like what this is what already I have done through these months. Yeah, so this is my time schedule. And then I will go with the conclusion part. For finally I have the conclusion. So as a conclusion, I think my project like demonstrate a full hallucination detection pipeline like that estimate estimate the token level risk using the hidden state probing, and it can highlight the specific risky as it mean like highlight the specific risky span to improve the explainability. So the current POC work from the generation through scoring and span highlighting, and it is reproducible. And next I will like I think to like I will focus, definitely I will focus on improving like accuracy and robustness using the better training data and clear evaluation and like wider testing. So then I will have my reference section. So finally, so thank you part, so thank you for listening.